So I want to show you what row operations are and then how to solve a system on your calculator mostly. Okay, but I want to kind of give you a little bit of an idea of what row operations are. Okay, so to begin with, I'm only going to talk through this. I just want to show you what we try to accomplish on this when we're doing row operations. So what you can do is when you have a system of equations, you can do these things. You can multiply a row by a number. Okay, that's kind of like that problem on the board over there. You know, we multiplied the top equation by something and the bottom equation by something. When you're solving a system of equations, you can multiply the rows by something, and then you can add them together. Another thing you can do is when you're doing a matrix, you can just change the rows. It doesn't matter what order the equations are put in. You can flip-flop the rows, and then you can basically just add the rows together. It's the same thing that you do when you solve by elimination. Okay, you multiply a row by something, you add the rows together, and then you get another equation when you do that. I'm going to show you kind of the terminology on this first of all and what this means, and that's what we're going to mostly do in here is learn the terminology. We're not probably ever going to do a matrix in this class where you do what's called Gaussian Jordan elimination, because it's probably for this level of a class and what you are doing, it's probably only worth showing you the overall idea of what's going on and then let the calculator solve the problem for you. That's usually what we do in this class. So first of all, if you see R1, that represents row 1 of your matrix. If you see R2, that's the second row, and so forth. If you see R1 double arrow R2, it just means you change the rows, okay? And you can do that. You can just change the rows anytime you want to. If you see this statement, this would say that you take whatever's in row 1 and multiply it by 3, and then you plug it in back into that row 1. You're only going to probably follow this until I do something specific, but just to get you the terminology, this statement would say add row 1 and row 2 together, get the result, and put it in row 1. You replace the original row 1 with that. This one says take 2 times row 2 minus 3 times row 1 and replace the result in R2. When you have that single arrow, that tells you where you put the result. So that's how that's going to go. Now, this example I gave you this is showing a method. I'm not going to go through the method, but ultimately what you're going to learn how to do is this would be a system of equations. I just want you to pay attention to what the goal is. So when I write the augmented matrix, that's 1, 2, 3, 9, 2, negative 1, 8, 3, 0, negative 1, 3. That's your augmented matrix. Okay, now I'm going to just sort of explain it this way. If you do row operations, which we're going to learn how to do a little bit, you could eventually turn this matrix into this, okay, where you have 1, 0, 0, 2, 0, 1, 0, negative 1, 0, 0, 1, 3. And by doing that, this gives the answer. That's x equals 2, that's y equals negative 1, that's z equals 3. Now, I'm not going to require you guys to know how to do that algebraically. Okay, it's not hard, but it takes a while to do that, and there's a lot of arithmetic in there. But what I want you to know is our goal is to try to change that into that. So that x is going to have a 1 there, 2 zeros, and then the answer. The y is here, 2 zeros, and then the answer, and then the z is here. You have kind of a column for x, a column for y, and a column for z. Does that make sense? Don't worry about how we get there. That's not going to be the point. Your calculator is going to get you there. Okay, it's going to do what's called Gaussian elimination and put this in a reduced form. You need to know the reduced form and what it looks like and what the calculator is doing for you. Okay, so what this is, and I'm not going to go through this on the next page, this is the process that goes through to solve that problem. All I want you all to do is to understand the row operation terminology and what it means by that. That's it. So that's what we're going to work on. And then we'll work on teaching you how to do this on the calculator. Okay, so I'm giving you this augmented matrix. One thing that I want you to write down on this is this would really mean this. The system of equations would be negative 1x plus 2y equals -3. The second one would be 6x minus 3y equals 12. I do want you to write that down because that's what the matrix represents, is the system of equations. Okay, so that's what that is. Okay. All right, now this is just learning a little terminology here. All right, so whenever you see this, that double arrow, all that means you're going to do is you're going to switch the order the rows are in. Okay, so what you're going to do on this result here is you just write everything backwards. So you flip-flop the rows. So it'd be 6, -3, 12, then -1, 2, -3. That's the easiest row operation. Okay, you can do that. It doesn't matter what order your equations are in. You're still going to get the same answer if you were to solve the system of equations. Okay, all right. Now the next one goes like this. Yeah, go ahead.
I was just, I don't understand where how you got those numbers.
I made them up.
Really?
I just made up a matrix. Okay, like that. -1, 2, -3, 6, -3, 12 is just a arbitrary matrix I made up. Okay, but what it would represent is this system of equations. And you were working on system of equations today in your Math 93, so that's what it represents. Okay, I just made that up. Yeah, you got something?
Yeah, is it just like a rule that the first column is always X? And
Yeah,
then Y?
exactly. Yeah, so what it ends up being is, that's what we were talking about, is there's your X's, there's your Y's, that's your equal sign, that's what they're equal to. So it turns out that all that matters in the problem is the numbers and how you organize it into that matrix. That's what matters. So that's what we're doing, is we're doing a system of equations. Okay? All right, now watch carefully what I do on this, okay? You're going to put something in row 2, okay? So the first thing is you're not putting anything in row 1, so you're just going to write row 1 as it originally is in the matrix. So you have -1, 2, -3. That doesn't change. Okay, you can learn to do this in your head too. So what's going to go in row 2 is just adding them together. It says take row 1 plus row 2. Now I'm going to write this at the side. You don't have to necessarily do this because you can do this in your head. That's what you'll learn to do. So what we're going to do is just add those two rows together. That would be a 5. That's a -1. And then that would be a 9. So that result gets replaced in row 2. So you put 5, -1, 9 like that. Don't worry about why I'm doing that. So I'm just trying to teach you the terminology of the idea of what a row operation is. Okay, so what did I do? I added row 1 to row 2, and I plugged it in for row 2. Does that make sense? I didn't do anything with row 1 because the row operation didn't tell me to do that.
Why is it -2?
What's that?
Why is it -2?
Why is what -2? Oh, I don't know. That's a good point. That should be +2. Yeah, I made a mistake there. So that's a 2. Yeah, good observation. All right. So let's see. This one. Okay, where do you put the calculation in? Row 1 or row 2? Okay, that's the key, is like that. Row 1's going to change. Because of that, row 2 is not going to change. So that is 6, -3, 12. So that's not going to change. Now we just do exactly what this tells us to do. Okay, now you have to be kind of careful about how you do this. Now I'm going to kind of write this scratch work over at the side. You don't have to write it down. I want you to just see what I'm doing. I'm going to do row 2 minus row 1. So focus on that. You're going to do 6 minus -1. Okay, you're doing it in that order because that's what it says. So 6 minus -1 is 7. So that's what goes there. Okay. Then you're going to go to the next part right here. You're going to do row 2 minus row 1. So that's now -3 minus 2. So that's -5. Most of this you're just going to do in your head. You write it down if you need to on scratch paper. Then the last thing is 12 minus -3. So that's equal to 15. Okay, so what I did is I just did each element in row 2 minus the corresponding in row 1. Then I substituted it in for row 1. Does that make sense what it did?
No.
Okay, again, I just did, look at this, 6 minus -1, -3 minus 2, and then 12 minus -3.
How do you tell what row changed?
Okay,
Like row 1 is placed.
okay, first thing you have to do is we're putting it in the result in row 1. That's what that tells you. Like this one, the result goes in R2, row 2. This one, the result goes in R1. Okay? This is the calculation you do, and then replace it in that spot.
How do you do the A?
How do I do what?
A.
That's switching two rows. Okay, when you have double arrow, that just means switch it. So that's what I did, switch the rows. Anytime you have a double arrow, that's all that means. And then these things are just meaning, okay, add row 1 and row 2, but put the result in R2. That's what you got to understand is what the meaning of that statement is. That's the idea. Okay? Okay, all right. So let's see. Let's look at the next thing here. Okay, so start with your matrix. Go ahead.
You just want to follow what you're doing. So please
I understand. I'm going about the speed that I have to go. Okay? And I sort of have things I have to do. Okay, let me ask this question. Where do I put the result in? Row 2. That's why I'm putting the horizontal or a shaded line there right there. What am I going to do with row 1? Nothing. So I just write down the -1, 2, -3, like that. Okay, yeah.
How come you do nothing? Like, how do you know it's row 1?
How do I know what?
Like, how do you know it's -1, 2, and -3?
Because that's the problem. We're looking at this problem right here.
But how come the other one starts 7, or C goes 7 minus
Because I did a row operation. I changed it. Okay, so this C, see, I've been trying to, as I'm teaching this, to highlight where we're putting this in. That's why I'm doing that. Okay, so what I did was I did R2 minus R1, then I put it there. That's why it changed. Okay?
Oh, so whatever's before that arrow is going to be...
That's the arithmetic you're going to do, and you're going to put it in this spot.
Wait, so then how come, like, the first row in D wouldn't be 12, 9, then, like, why would you just multiply row 2 times 2?
Here's what the deal is. This is what I'm trying to show you. Okay. Whatever I do is going to go in row 2. Okay? If that doesn't say row 1, so that means that's not going to change. Now I'm not going to do anything at all. I'm just going to do 2 times row 2 and put it there. That's what that means. And you can do this in your head. If you do 2 times row 2, what are you going to have? 12, -6, 24, right? Then you're going to put it there. But row 1's not going to change because of that. That says it's row 2 that changes. The problem be above. Row 2 changed. This row, run changed. That's why I'm highlighting what I'm doing. I'm highlighting the row that's going to change. You see what I mean? The other one's going to stay the same. Does that make sense? Okay. All right. Just kind of learning the terminology of what it means is the idea. Okay. Now, what I'm going to do is I'm going to double row 2. You can do that in your head. You're doing 2 times 6, 2 times -3, and then 2 times 12 like that. Okay, well, you're going to get 12, -6, 24. So row 1 stayed the same, and then I doubled row 2, and then I replaced it in the original row 2. Okay, does that make sense? Okay, it's part of just learning the concept of what the language is saying to do here. Okay. Okay, let's look at this next one here. And remember, I'm looking at the original problem, okay? So this is what I can tell some of you are having trouble with. What's going to change on this problem? Row 1 or row 2? Row 1. Row 1. What's going to stay the same? Row 2. So you go ahead and write row 2 down in the original. That's how you want to start that, is like that. Okay? So again, because that says row 1, that's going to change, but the other one just stays the same. So that's 6, -312. Again, I'm looking at the original problem that I got highlighted in blue there. Okay. Now, a lot of this stuff is kind of hard to do in your head, so I'm going to kind of show you what I'm doing on this now, just kind of at the side here. Okay, so what I'm going to do, it says that you take 3 times row 2. Okay, so I'm going to take the original row 2, and I'm going to multiply all of the numbers by 3. Okay, and you can write this down if you need to. So what I'm going to do is I'm just multiplying row 2 by 3. Okay, what that's going to give me is that's going to give me 18, -9, and 36. I'm tripling row 2. That's what that 3R2 says. Then I'm going to double R2. Okay, so I'm going to, or R1, that says 2R1. So I'm going to double everything in row 1. Okay, like that. Okay, that's going to be 2 times -1 is -2. 2 times 2 is 4. 2 times -3 is -6. Okay, so I tripled row 2. I doubled row 1. Now what are you going to do with those two things? You're going to add it, right? Okay, so you're going to add this together. Okay, so that's going to be 18 added to -2 is 16. -9 added to 4 is -5. 36 added to -6 is 30. So that will give 16, -5, and 30 like that. Okay, I tripled row 2, I doubled row 1, then I added them together, and I plugged it in R1. That's what that told me to do. Does that make sense? Okay, a lot of these you'll be able to do in your head, but if you can't do it in your head, write out on your scratch paper kind of what I'm doing there. Okay? Okay, so let me ask this. See if we're getting this down. Okay, what changes in this problem? Which row changes? R1. What stays the same? R2. Okay, that's what you got to have. So what I'm going to do is since R1 is where the change gets put in, I'm going to highlight that, and then row 2, I just write it down as it originally was, 6, -3, 12, like that. Okay? All right, now I'll kind of do the calculation on the side here, because this one's kind of hard to do in your head. Okay, so what we're going to do is it says do -2R1, and then we're going to do -4R2, and then we'll just add them together. That's the way I'm going to look at this. What's that?
It says minus.
It does, but what I could do is I could just multiply row 1 by -2, multiply R2 by -4, and then add them together. Okay, you can do that, or you could, because it's the same. It's just plus -4R2. Okay, so I'm going to try to do this in my head. Okay, just double up. Let's multiply all those numbers by -2. -2 times -1 is 2. 2 times -2 is -4. -3 times -2 is 6. What I did is I just took row 1 in the original and multiplied it by -2. Now I'm going to take row 2 and multiply it by -4. 6 times -4 is -24. 6 times -3 is -18. 6 times 12 is, I think, 76. Hold on, I'm doing the wrong thing. -4, sorry. Okay, so I'm doing, let's see, 6 times -4 is -24. 6 times -3 is -18. And then -4 times 12 is -48. Okay, so what I did on, no. Sometimes I can't talk and write at the same time. Okay, -3 times -4 is 12. -4 times 6 is -24. 12 times -4 is -48. So that's what I did is I multiplied everything in row 1 by -2, everything in row 2 by -4. Now I'm going to add them together. So that's going to be -22, 8, and -42. That's what gets plugged into this row, is that then. Okay? All right, and sometimes when you have to multiply rows and add them, it's hard to do in your head, so you got to write things down, okay? All right, so I'm going to have you work with this a little bit and just kind of see what you can do on just a few problems, give you a little time to see if you can process this and see if we get the hang of it here, okay? So I'm going to let you work on these on your own for a few minutes, and we'll see how you do. And I'm going to shut off the computer here. I'm going to work them out while you're working them out. Just go ahead and go for it. See how many of these you can do. The first one's the easiest one. The second one, it'll get a little harder when you get to the last. The last one to me is the hardest one. Okay, but just see if you understand the language now.
We still gonna come back to that problem in 4.1?
What's that?
We still gonna come back to that problem in 4.1?
Next time. I think I typed something wrong on that problem. With practice, you can do a lot of these in your head. To me, it's a little harder for me to do like number 5 in my head. I have to kind of think about what I'm doing. So I'm going to kind of go through these things here and kind of see what we did. What did you do on number 1? That's the easiest one. Hopefully you switched the rows, okay? That's what that means. And I'll put these up here and you can kind of see how you're doing. And I'll go through some of these that kind of what we're doing. So the first one just, of course, means switch rows. So you want to make sure on the first one you did that, okay? Now the next one, again, what I was showing you is kind of this idea. Row 1 is what changes. That's why I highlighted it. So I just brought down row 2 as it is. Okay, that to me is the way you always start this. And then this just says add row 1 and row 2. And you can do that in your head. If you add row 1 and row 2, you're going to get -1, 4, 12. So that one's usually pretty easy for us to do in the process because you're just adding things. Okay, is everybody with me there okay? And what that means? Okay. All right. The next one, R2 is what changes. That's why I highlighted that. Therefore, row 1 stays the same. Now, what you're doing on this is you're subtracting row 1 minus row 2. And I just sort of wrote out what I was doing on this. If I'm doing row 1 minus row 2, I'm doing 1 subtract -2, 0 subtract 4, 2 subtract 10. Okay, so I did those things right there. 1 subtract -2 is 3. 0 right 4 is -4, and the last one's -8. So I did that. So to me, those first three problems are pretty simple to process in your head. Same thing with number 4. It's not too bad. Okay, are you guys okay so far? I can't tell. Mainly it's arithmetic and understanding the language of what I'm trying to teach you. Okay, row 2 changes. I highlighted that. Row 1, hold on, did the teacher mess up on that one?
Yes.
It did, okay. Row 1 stays the same. I don't have any idea why I did that. Okay, so row 1 stays the same. Okay, so that'd be 1, 0, 2. Okay. And then what I did, this one's pretty easy to do in
You
your
got
head.
row 2 the same too.
Did I?
Yep.
Did I not do anything?
You did something.
Maybe I didn't do the problem, okay? Jeez, okay. Yeah, this one goes like this, okay? So, yeah, row 2 is going to change, and then row 1 is going to stay the same. So row 1 was 1, 0, 2, okay? Then I just do this. I just multiply all these numbers right here in row 1 like this, okay? Well, I think that would be -2 times 1, -2 times 0, -2 times 2. So I got that result, and that just plugged in. It just turned out that it ended up being the same anyway, okay? It just did. It turned, whoops, that's not a 10. That's -204. Okay, so I didn't do that right. I just wrote the wrong thing on there. Okay, so I got that. That's what you should have got. Okay? And then the last one is probably the one that's probably the hardest one to do, is what we're doing on this one then again is I've got row 1 changes, so I highlighted that. And then I'm just doing 2 times row 2. So I did that when I did 2 times row 2. Did I mess that up too? I'm gonna need a day. I need to just like go on vacation or something. I don't know. I have days like this too. Okay, so let's see. Let me do this carefully. So 2 times row 2 would be 2 times. So there I go again. I'm already screwing up. Okay, so row 2 is -2, 4, and 10. Okay, so I'm going to do 2 times row 2. So that's going to be -4, 8, and 20. And then I just add row 1 to it. And row 1 was 1, 0, 2. So that should be -3, 8, 22. Okay, that's what that should be. Is that better?
Yes.
Yes? Okay, so yeah, that result is going to be -3, 8, 22. Row 2 stays the same. That's still -2, 4, 10. Okay? All right, you guys with me? Okay? Okay, so get your calculator out. On the next page, I'll kind of show you what we're leading up to. All right, so we're going to do this on the calculator. So you need to do this with me, and I've typed out the steps that you do on this, and you'll get this down. It's kind of a long process for putting a matrix in your calculator. So the first thing that we're going to do on this problem is we're going to write this as an augmented matrix, and I'm going to show you how to solve this on your calculator. Okay. First of all, write down your augmented matrix. Your augmented matrix, the first row is 3, -2, 6. Put a bar there. And then 4, -3, 6 like that. So you kind of have a column for x1, a column for x2, and then the numbers. And you can use x and y, or you can use x1, x2. It means the same thing. Those are just the names of my variables. Now, what you want to try to do is follow this that's on my handout here. Just do what it says. Okay, so I'm going to start by going, opening up the matrix command. So you should have a matrix menu right above the x to the -1. That should be in the same place on every calculator. So you go second, x to the -1, that opens up the matrix menu, and then you look for names, okay? Now, you will have maybe different things. It depends on whether you've used your calculator before or not. I'm going to put it in matrix A. So what I do is I just press, I go ahead and go to edit. Okay, like that. So I need to go to edit, then I need to press enter. So I'm going to put the first matrix in A. You can put the matrix in any of these that are on there. It doesn't matter. I'm going to put it in A. All right. So what you got to do is, how many rows does this have? 2 rows, 3 columns, right? So you need to put that in the number of rows and columns. So what you do is you just put 2 there, and you can press enter and it'll go to the next place, I think, and then 3. Now all that does is it just sets it up so it's got 2 rows and 3 columns. Now you just start putting the numbers in. So just take your augmented matrix, start putting the numbers in. So we'd have 3, -2, and 6, and then we have 4. Let's see, I keep pressing enter after each one, -3, and then 6 like that. Okay, so that puts your matrix in. So basically, in a sense, you've now got all of your numbers in the matrix. Okay, that's what I want to make sure that you do first. Okay, is everybody with me? Okay, you getting the numbers in? Okay, is that working? All right, now we're kind of do this now. So we're basically, now that the matrix is in, you want to quit and go to a clear screen. This quit button, you want to just go second mode. So I'm going to go second mode, and that just takes you to a clear screen, because now we're going to do something with the matrix. So all you do at the beginning is put your matrix in. Now part B of this, you start doing this, we're going to do have this solve this matrix for us. So what you do is you go second x to the -1. Again, just open up your matrix menu. Then you go to the math command, like that. Then you need to go way down. You have to go way down until you find something that says RREF. That should be way down at the bottom like that. That stands for reduced row echelon form. That's what you're always going to put this in, is that. Always that one, not the one that's above it with 1R. Then you press enter. So just press enter. Okay. Now you got to put the matrix in. Okay. So what you have to do from this is you have to go back to the matrix command. Okay, like this. So go back to your matrix thing. So go second x to the -1. Okay, do that, and then just highlight A, and then press enter. Okay, so you want to do that. Ultimately, what you're trying to do in this problem is get that in your calculator. Reduced RREF of whatever matrix you put it in, then you press enter, and then you'll get the answer to the problem we're looking for. Okay, students, it sometimes takes a little time to get this figured out, but you should, if you did that right, you should end up getting this. Okay, and what this means is, what you want to write down is, this really means x1 plus 0x2 equals 6. And the second row says 0x1 plus 1x2 is equal to 6. So what it means is, it just means the answer is x1 is 6, y1 is 6. So all these things we've learned, like the graphing technique, the substitution, elimination, that's how a computer does a matrix. Okay, it does row operations. I want to just kind of give you a little background for what row operations. It runs through and does that, and that's what the answer is. Okay, the other thing I want to show you on this is we're just going to check the answer real quick, and then we'll move on to the next thing here. And so let's check this. The system we're doing is 3x1 minus 2x2 equals 6. And then we got 4x1 minus 3x2 equals 6. So what would you do to tell you're right on this problem anyway? You plug it in. Exactly right. Okay. So basically you would just do 3 times 6 minus 2 times 6. Both x1 and x2 are 6s. So that would be 18 minus 12. That's equal to 6. That's what it's supposed to be. Okay, then you do the next one. 4 times 6 minus 3 times 6. Okay, that's equal to 24 minus 18. That's also 6. So you can tell you're right. And now if you put your matrix correctly in your calculator, the computer is going to get it right. Okay, you just got to make sure that you've entered everything right in your calculator. Okay, so that's something that you want to know how to do. That's a technology problem. It's just simply knowing how to do that in your graphing calculator. All right, how many people did that okay on their calculator? I have a feeling maybe you're getting better on our calculators in here.
So,
Yeah.
just to clarify, the X1 is the same as the A?
Yeah. You have two variables. You're either going to see me use X and Y or X1,
I'm just
X2.
making sure.
No, that's a good question. That's fine. Okay, so we're going to